Namaskar, welcome to Divine Chemistry. I am Divyashri. In the previous videos, we have discussed on how to draw the Lewis structures. We have also learned to calculate the formal charts, but we have also discussed on some of the limitations of the Lewis-Cossel approach. So some of those limitations were overcome by the Valence Bond Theory. So this video will basically be an introduction on the Valence Bond Theory. So let's get started. Now, the Valence Bond theory was developed by Hitler and London in 1927 and was modified by Pauling and Slater in 1931. The orbitals having unpaired electrons of anti-spin overlaps with each other. So, this is what the Valence Bond theory said. And this point, I will be discussing this particular point in the coming slide. So, till then, we will learn the other points. What it says is that after overlapping, a new localized bond orbital is formed which has maximum probability of finding electrons. Now what happens? The name itself suggests that the valence bond theory the name says that the outermost orbitals, that means the valence orbitals, participates during the bond formation. And after the overlapping takes place, a bond is formed, that is a covalent bond is formed, and that particular bond will have the maximum probability of finding the shared electrons. Now, the overlapping of different types gives the sigma and pi bond. Now, you all must be very familiar with the term sigma and pi bonds. So, the valence bond theory was the theory which gave the concept of what is a sigma bond or what is a pi bond. So, this was the theory which gave an idea firstly of the sigma and the pi bonds. Now, we will discuss this second point which says that orbitals having unpaired electrons of anti-spin overlaps with each other. So, what it says is that during the overlap, suppose A and B are atomic orbitals, then both A and B should have opposite spins. That means if one has a spin of plus half, then the another should have a spin of minus half. Only then overlapping is possible. And both the orbitals that will be participate in overlapping should be half filled. If the orbitals are fully filled, if both the orbitals are fully filled, then overlapping is not possible. So, during the formation of a covalent bond, we can see that both A and B are half filled and have opposite spins, and thus there is a formation of the covalent bond. And in the coordinate bond, suppose A is completely filled, then B should be empty. Then A will be completely donating both of its electrons in the formation of the bond, and it will result in the formation of coordinate bond. Now, after the formation of covalent and coordinate bond, as I have already mentioned, there is no such difference between the covalent or the coordinate bond after the formation of the bonds. Now let's learn about sigma bond. Now sigma bond is formed by head-on overlap between atomic orbitals. That means the overlapping should be on the internuclear axis, and the overlapping should be head-on overlapping. Here you can see both the s orbitals are overlapping. Here one s orbital and one p orbital is overlapping on the internuclear axis, head-on overlapping. And thirdly, we can see two pz orbitals are overlapping to give rise to a sigma bond. So, during the formation of a sigma bond, there is only one interacting lobe, means there is overlapping on only one lobe, and the overlapping should be on the internuclear axis. Now, you might be noticing that the internuclear axis here, it is considered as the z axis. This is because by convention, if it is not specifically mentioned, then we will automatically take the z axis as the internuclear axis. Now, what is a pi bond? Now, pi bond is formed by lateral overlap between atomic orbitals, means by sidewise overlap. Now, two lobes of an orbital on one atom overlaps two lobes of an orbital on another atom, and this overlap occurs laterally. These points will be clear if we focus on the pictures. So, here you can see that pi bonds are characterized by side-to-side overlap, and electron density above and below the internuclear axis is maximum. So, what it says is that you can see that two pi orbitals, these are two p orbitals, both the p orbitals are overlapping sideways, and these zones which have been colored darkly, so these zones, these have the maximum probability of finding the electrons, or these have the maximum electron density. That means you can see when two p orbitals are coming together, they are overlapping, and they are giving rise to pp overlap, and pi bond is formed. So here one point to note is that during the formation of a pi bond, there should be two interacting lobes, but during the formation of a sigma bond, only one lobe interaction is possible. So that was all for today's video. Thank you so much for listening to me, and thank you so much for your patience. If you like the video, please give it a big thumbs up, and yes, please do subscribe to the channel. I'll be much happy for that. And stay at home, stay safe, take care. Thank you.